Welcome to all, the second lecture of the Verilog HDL and a beginner to advanced series. Firstly, I like to discuss about the recap of the lecture 1. In the lecture 1, we discuss about what is a Verilog, importance of Verilog, difference between Verilog and another language, the abstraction level, and the basic syntax of a Verilog. You can refer that the video on the channel. Okay, let's start today's agenda. Today we discussed about the gate primitive, a type of exception level. So what is a gate primitive? Gate primitive are the predefined Verilog component that directly represent logic gates such as AND, OR, NOT, NAND, NOR, XOR and XNOR. The all gate have a different operations. Why the gate primitives is a basic or a foundation of the Verilog we can say. So the reason of a why gate primitive modeling is very important. It is the closest to a real hardware. The combination of a gates make a circuit. For example, we take the half adder. Half adder is a full circuit. The combination of etc. gates. Okay. So there is a basic syntax of a gate primitive. The gate name. For example, we can take the AND gate. So AND bracket output. The basic mistakes or a beginner mistake is not returning the output first. There are the three rules. Output come first. Not gate has only input. We will see the all gates in a brief. Semicolon is a mandatory. Okay. So let's start to discuss about the all gates. First we discuss about the NOT gate. NOT gate, or we can say the toggling gate. Input, we can say the input A is 0 and 1. The output of a input 0 is a 1 and input 1 output is 0. It toggles the input. Okay, there is a basic symbol of a NOT gate. Second is a AND gate. It is the multiplication type. The input AB, the multiplication of a 0 0 comes 0 0 1 comes 0 1 0 comes 0 1 1 comes 1. It is the basic symbol. Similarly for a OR gate we can say it is the addition. The input are 0 0 0 1 1 0 1 1 and output is 0. So 0 plus 1 is 1, 1 plus 0 is 1 and 1 1 1. Okay, it is the basic symbol. NOR gate, or we can say NOT plus OR. First we have covered the OR gate. Okay, 0 1 1 1 1. We can see the output series. Okay, if we send this Y into a NOT input, so how we get the output 1 0 0 0. Okay, same for a NOR gate 1 0 0 0. Okay, this is a basic symbol for a same NOT plus AND gate. In the AND gate, we have seen the output series comes 0 0 0 1. Okay, forward this output in as an input in a odd NOT gate. So we get as a output is a 1 1 1 0. Okay, same output represent in a AND gate. Okay, NAND gate we can combination of a NOT and AND. It is a basic symbol of a NAND gate. After this, this is the exclusive gate, exclusive OR. When the input are the different, then only the output will 1, or we can say the true. When the input are the same, the output will 0. Okay, so it is the XOR. It is the basic symbol of XOR. And the next is XNOR. We can say the NOT plus XOR. The output of a XOR is 0 1 1 0. We will consider as a input of a NOT gate, and as output of a NOT gate we get 1001 as the same output of a XNOR. We have discussed about the all the gates. So let's start writing the code. So there is a software, online software, EDA Playground, on which we are going to write our code. Simply search EDA Playground and open this link. On the screen, we have the two boxes, right side for a design code and left side for a test bench code. So first on this screen, we have to refer this language and libraries. So test bench plus design we are using for a Verilog. So we choose Verilog, and not another changes in this section comes in a tools and simulation. We have to choose our simulation. So I am preferring the Icarus Verilog 12.0. Select this, and to observe the waveform, I want to tick on the open EP wave after the run. So I will select the checkbox. So we have to write our design code right side and test bench code on the left side. But what is a test bench? So test bench is it is a confirmation of a design code. The design code is a working or not properly. So I have written the code of a basic all gate. So first we write the module keyword, and we can give the any name to the module. First we are writing input A, input B. Okay, the output as a keyword, and the name or a variable name, the n underscore y or underscore y, and for all gates. Okay, so as we seen the basic syntax of a gate primitives, the gate name in bracket, the output come first. So I have written and underscore y first, the input A and B for or, for not, for and, nor, XNOR, and XOR. Okay, so we can see in the NOT gate there is only one input A. Okay, it is the stage bench I have written. We will briefly discuss about the test bench in further lecture. For now, we can see the waveform on the input of a 0 0. The AND operation is a addition, so 0. NAND operation is a NOT plus AND, so 1. We can see the output of a NOT OR gate. 0 plus 0 is 0. So NOT plus OR, it will be 1. Okay, NOT gate, the input for a NOT gate is 0, so it will toggle 0 to 1. And for XNOR, there is an input of a 0 0, the same input which gives the 0 as a output for a XOR. For NOT plus XNOR is a XNOR, so we get a 1 output. Okay, you understand all the gate primitives or gate operations. This is the waveform. For now, we will stop this lecture. Thank you for watching this video. Please like, subscribe, and share the video as much as possible. Thank you.